Our project is on the Calvin cycle. It occurs in the stroma and it is light independent, although it is dependent upon light dependent reactions. It happens after light dependent reactions in the thylakoids. The output of the light dependent reactions are some NADPH and much more ATP, which are the input of the Calvin cycle, along with carbon dioxide. It happens in the stroma all over the place. The output is G3P, which combines to form sugars like glucose. The three phases in the Calvin cycle, as seen here, are carbon fixation, reduction, and regeneration. The big idea is that carbon dioxide comes into the Calvin cycle to form glucose, while the other molecules keep recycling in the cycle.
The first part or the first step in Calvin cycle is carbon fixation, which is fixing the carbon from carbon dioxide from the atmosphere into a very unstable 6 carbon molecule with the enzyme called Rubisco, which is the most abundant protein on Earth because it's a very crucial enzyme that fixes carbon from the atmosphere and then produces glucose, which is the source of energy for all organisms on Earth. And the Rubisco enzyme is a very complex protein molecule, and it has a one problem, and it's called photorespiration. So what is photorespiration? Photorespiration is when Rubisco, instead of fixing carbon from carbon dioxide, uses oxygen instead, and then it produces molecules that are not as useful as glucose, and then it because of the photorespiration, which is using oxygen instead of carbon dioxide.
Um, the next stage in the Calvin cycle is called the regeneration. And pretty much what we had the reduction and other reactions, and what we ended up with is a bunch of G3Ps. So for every CO2, you have two G3Ps that are being made. So pretty much you have all these G3Ps, and for only 1 out of 6 are actually used to make glucose. So the Calvin cycle happens all over the stroma, it's all over the place, and then on average the ratio for every 6 G3Ps that are made, 1 gets out. And the other 5 go through the regeneration process, in which each G3P takes up 1 ATP with RU to make 3 RUBPs. And in the next slide, you will see the reaction for it. So you have here on the bottom, I don't have a thing. Here on the bottom, you have the 6 G3Ps, and then as you see, it took the ATPs, 3 ATPs to make them into 3 RUBPs, and you can see that actually the amount of carbons is preserved because RUBP is a 5-carbon molecule and G3P is a 3-carbon molecule. So 5 G3Ps multiplied, so 5 G3Ps times 3, that's 15, and then you have, so 3 RUBPs have 15 carbons total. So the number of carbons is preserved. And pretty much that's what allows a Calvin cycle to happen over and over again, because Rubisco can only bind with RUBP and CO2, so you needed that regeneration to happen in order for it to work out. So overall, go over the Calvin cycle in a nutshell. You have the two inputs. The numbers kind of matter. These numbers for 3 CO2, 9 ATP, 3 NADPHs, they're all just numbers so that for 1 glucose to be made. But actually, pretty much for every CO2, you have 2 G3Ps being made. And the Calvin cycle numbers, when you look at the diagrams in the textbooks, that's just 3 cycles happening so that you end up having 1 glucose being an output of all that. But anyway, so you have CO2 going in, and then ATP with NADPH that came from the light-dependent reactions, or the energy from those are used to turn the CO2 into G3Ps. So 1 output of G3P for every just the cycle, and then 3 RUPPs are also kind of produced, but the real output is just G3P. And so the final equation in order to make 1 glucose with the numbers is 18 ATP and 12 NADPHs with 6 CO2s, will create two GDPs output. So actually 12 are made, but 2 get taken out, which will create 1 glucose. And something about the G3P itself, the molecule itself, actually, you can see right below, there is the molecular diagram for G3P. And the thing about it is it comes with a phosphorus built in with it. And the thing is, the reason, since there's a phosphorus right there, it makes it really easy for it to combine with other G3Ps to form sugars such as glucose and such. So you would think the output is just glucose, but the output is something really close to glucose, and just very simply it can become it. So yeah, that is the Calvin cycle in a nutshell. Hope you enjoyed, and here's our music video.
Solo. Open Calvin cycle. Calvin cycle. So as the CO2 goes into the Calvin cycle, it comes with RUBP. It's time for Rubis goes to rival. It only needs 6 ATP to reduce NADPH to NADP+. Calvin cycle A, and this all came from 6,3-PGA. Initially there were 6 carbons in 3-PGA. It was unstable, then broke to form 3-PGA. Calvin cycle A.
The Calvin cycle makes G3P to form glucose, hey, which we need most, hey. The Calvin cycle makes G3P to form glucose, hey, which we need most, hey. 2,3-GP come to form glucose.
Open Calvin cycle. Calvin cycle. Hop, hop, hop. Open Calvin cycle. Calvin cycle. Hop, hop, hop. Open Calvin cycle.
Hey, Mrs. Brown. Nope, 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 nope. Another notebook. Hey, Mrs. Brown. Nope, 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 nope. Hey, hey, hey. 6 G3Ps are made, but only 1 gets out. The other 5 go through again, and this is called recycle. 5 G3Ps need ATPs to form RUBPs, and then it goes again.
Calvin cycle A, and this all came from 6,3-PGA. Initially there were 6 carbons in 3-PGA. It was unstable, then broke to form 3-PGA. Calvin cycle A.
The Calvin cycle makes G3P to form glucose, hey, which we need most, hey. The Calvin cycle makes G3P to form glucose, hey, which we need most, hey. 2,3-GP come to form glucose.
Open Calvin cycle. Calvin cycle. Hop, hop, hop. Open Calvin cycle. Calvin cycle. Hop, hop, hop. Open Calvin cycle.
Hey, Mrs. Brown. Nope, 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 nope. Another notebook. Hey, Mrs. Brown. Nope, 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 nope. Mrs. Brown, notebooks due tomorrow. Please, please make it stop. My hands are about to drop.
Mrs. Brown, it's late and I'm alone. Help, help, it's 4 a.m. and I don't know any bio except
Open
Calvin cycle.
Hey, Mrs. Brown. Nope, 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 nope. Another notebook. Hey, Mrs. Brown. Nope, nope, nope.
Open Calvin cycle.